mathematicians, we see one nice problem. It looks like a linear algebra problem because there is matrices and they have given a vector to calculate something, but actually it is a problem in complex analysis. Okay, let me phrase the question. Let theta be a primitive fifth root of unity. Okay, then they have given this matrix A and they have defined a some inner product kind of thing. Now V modulus of V subscript A equal to square root of modulus of VA V transpose. Okay. Then the question is, if W equal to this vector, then what is modulus of WA? Okay. So before we get into this okay, so basically we want to calculate mod W subscript A. We calculate it. What we need to do, we have to find WA W transpose, and then we have to take modulus and we have to take square root. Okay, so we calculated WA W transpose. So W is this vector. Now if we want to find WA W transpose, so W is W is a 1 by 5 vector. Matrix is a 5 by 5 matrix. W transpose will be 5 by 1 vector. So if you multiply all of them, you will get so this 5 by 5 cancel, this 5 by 5 cancel. Basically, you will get a 1 by 1 a number. Okay, so this is actually a number. Then so this VA V transpose is a number. For that number, you have to take modulus and the square root. So let's calculate this number. So WA W transpose equal to, this is my W, this is my A, this is my W transpose. Now I multiply this this vector. So it is a 1 cross 5 vector into 5 by 5 matrix. What will I do? I'll multiply this row into this column, then this row into this column, this row into this column, and so on. What will I get? This row into this column will give me theta power minus 2. This row into this column will be theta power. There is a minus 1 here. Minus 1 into theta power minus 1. You get minus theta power minus 1. Okay. Similarly, this column, this row, this column, this row. Sorry, this row, this column, this row, this column, this row, this column will give me this vector. Then finally, I have put this vector. Okay. So now we have to multiply these two vectors. How do you multiply these two vectors? Basically, we are calculating the dot product of this vector, or you can see this is a 1 by 5 matrix, this is a 5 by 1 matrix. You can multiply them, you'll get a 1 by 1 vector. So theta power minus 2 into 1, we get theta power minus 2. Did I? Yes. So there is a typo, it should be plus. Yeah. Minus theta power minus 1 into minus 1 give me plus theta power minus 1. 1 into 1, 1. Theta into 1, theta minus theta power minus 2 into minus 1, theta square. Okay. So I have now this is 1 plus theta square plus theta power minus 1 plus theta power minus 2. So this theta power minus 1 and theta power minus 2 we want to modify it. Okay. So since theta is a primitive fifth root of unity, it means that its fifth power will be 1. Okay, that is the meaning of it is a if it is a any if it is a any fifth root of unity, if you raise it to fifth power, you will get 1. Okay. So far we haven't used the fact that it is a primitive fifth root of unity. We have just used the fact that it is a fifth root of unity. If it is a fifth root of unity, then you will get theta power 5 equal to 1. So if it is theta power 5 equal to 1, then theta square equal to theta power minus 3. So basically in both sides this equation you multiply by theta power minus 3, you will get. Similarly, theta power 4 equal to theta power minus 1. So now we can replace these two values here. So we get theta power minus 1 is theta power 4, theta power minus 2 is theta cube. So we get 1 plus theta square, theta cube plus theta power 4. This quantity is actually 0 if theta is a primitive nth root of unity, not just fifth root of unity. You take any primitive nth root of unity, then see if it is fifth root, we are summing till 4. If it is nth root, you have to sum till n minus 1. Okay. So let's see why this sum is equal to 0. Now we observe that, so let's define what is primitive nth root of unity. Primitive nth root of unity is a very important concept. Like in primitive nth root of unity itself, in complex analysis, there are many CSIR questions. So let W subscript n be the set of all nth root of unity. Okay, so there will be nth root of unity. So cardinality of this set will be n. Then this set form a group with respect to complex number multiplication. Okay. Now W belongs to Wn is said to be a primitive nth root of unity if W power n equal to should be 1. Okay. But this is true for every element of nth root of unity. If it is nth root of unity, then its power n should be 1. But primitive means that W power k not equal to 1 for all 1 less than or equal to k less than or equal to n minus 1. That means that the first time W to the power n, W to the power k will be 1 if k equal to n. Okay, only when k equal to n you get W power n equal to 1. For lesser numbers the power of W won't be 1. Okay, so that is the condition. Okay, this is the condition for primitive nth root of unity. So in this group, multiplication group, what is order of primitive nth root? So order of an element means, in a group order of an element means you multiply that number with itself. Okay, first time whenever identity comes, that is the order. Okay, now if it's primitive nth root of unity, you have to multiply itself with n time, then only you will get identity. Okay, therefore so n is the least number satisfying this condition. Therefore, order of the element W in the group Wn is equal to n. Okay, so it is a group of order n and has an element of order n. Therefore, set of all nth root of unity form a form a cyclic group of order n. Okay, so now we know what is primitive nth root of unity. So primitive nth root of unities are precisely the generators of this cyclic group Wn comma dot. Okay, let's see some examples. You take n equal to 3, then the n third root of unity are 1 plus I root 3 by 2, 1 minus I root 3 by 2. If you calculate cube of this number, you will get 1. Similarly, this number also. So these two numbers, any of this number can be taken as primitive nth root of unity. Okay, so this is a primitive nth root of unity. This is a primitive third root of unity. This is also primitive third root of unity. So if you take W to be this number, then if you calculate W square, you will get this number. Similarly, if you take W to be this number, then W square will be this number. Okay, so whenever we write the third root of unity, we always write 1 omega square. In that, omega is either this number or that number. Okay, so any primitive nth root of unity can be taken as W. So if this is W, then this will be W square. If this is W, this will be W square. Okay, so anyway, so I take this to be my W, then I get W power 0 is 1, W power 1, W square will be this number. So I get W3 equal to this set. Now if you look at Z3 has elements 0, 1, 2, then you just look at the powers under this number. This will give you the isomorphism between these two groups. Okay, so yeah, so one more example, you consider I minus I, sorry, 1 minus 1 I minus I. This is set of all fourth root of unity. Okay, now this minus 1 is not a primitive fourth root of unity because second power itself is 1. Okay, if it is a primitive fourth root of unity, fourth power only has to be 1. No lesser power should be equal to 1. Okay, therefore minus 1 is not a primitive fourth root of unity. Now you can check that I and minus I are primitive fourth root of unity because I power 1, I square, I cube, none of them are 1. Only I power 1, 4 equal to 1. Okay, similarly for minus I, therefore I and minus I are the primitive fourth root of unity. Now W power 4 can be written as I power 0, I square, I power 1, I cube. Why I square is minus 1, I power 1 is I cube will be, what is I cube? I cube will be minus I. Okay, because I square is minus 1, so I cube equal to I square into I, we get minus I. Okay, so now every element of W4, so since I is a primitive nth root of unity, every element of W4 can be written as this is like every element in the W4 can be written as power of the primitive nth root. Okay, so we get this is like W, this is W square, this is W cube, this is 1. Okay, So we take w equal, if you take w equal to I, then this is 1 w square w cube. Okay, then the isomorphism between w4 and z4 is again we look at the powers. Okay, now these two numbers I and I and minus I form a generators, because so usually what numbers form a generator, the powers appearing here should be relatively prime to 4. Okay, because in Z4 this 1 and 3 form a generator. Okay, so whichever number relatively prime to 4 form a generators to Z4. So in the nth root, if you write the nth root of unity also as a powers of primitive roots, then whichever power is relatively prime to this n, that will form a generators. Okay. Now in Zn, how many numbers are there that is relatively prime to n? That is precisely pi of n. Okay. So what is pi of n? That is Euler-Torsion function. Pi of n is equal to cardinality of this set. Set of all 1 less than or equal to k less than or equal to, sorry, 1 less than or equal to k less than n such that k comma n. So it should be relatively prime. So whichever number relatively prime to n, we collect that set. The cardinality of that set is pi of n. If you take any number from this set, it will be a generator for Zn. Okay. Therefore, the number of generators for Zn is pi of n. Since Zn and Wn are relatively prime, we get a number of generators for Wn is also pi of n, where Wn is the set of all nth root of unity. But the generators of Wn is precisely the primitive roots. Therefore, the number of primitive nth root of unity is equal to pi of n. Okay. Okay, good. Now we know the number of primitive nth root of unity. So we like consider we consider nth root of unity. So basically, you take a primitive nth root, then you write all the nth root of unity as the powers of w. Then all these numbers satisfies the polynomial z power n minus 1. Okay, now it is a nth degree polynomial. It will have exactly n roots in C. These are n numbers. Okay, therefore these numbers are the only roots of this polynomial. Okay, now sum of the roots of the polynomial is equal to minus coefficient of this term. Okay, you take any polynomial, then the coefficient of, if it is a polynomial of degree n, then the minus coefficient of, then the negative of coefficient of z power n minus 1 will be the sum of the roots of the polynomial. Okay, for let's do an example. You consider this polynomial x minus 2 into x minus 5, its roots are 2 and 3. So if we expand it, you get x square minus 5x plus 6. So it's a second degree polynomial. The negative of the coefficient of x power 1 will be the sum of the roots. Okay. Therefore, sum of the roots equal to coefficient of x power n minus 1. But you have to take a negative of the coefficient of x power n minus 1. Okay, therefore sum of the roots of this polynomial equal to coefficient of z power n minus 1. But the coefficient of z power n minus 1 is 0. But what is sum of the roots of this polynomial? So all the roots of this polynomial are these numbers. So we get 1 plus w plus etc. w power n minus 1. This is sum of the roots. So sum of the roots equal to coefficient of z power n minus 1. Negative of coefficient of z power n minus 1, but the coefficient of z power n minus 1 is 0, so we get 1 plus w plus etc. plus w n minus 1 equal to 0. Okay, so if w is a primitive nth root of unity, then 1 plus w plus etc. plus w n minus 1 equal to 0. Okay, now we come to the problem. So in the problem, we proved that since theta is fifth root of unity, primitive fifth root of unity, we get 1 plus theta square plus theta cube plus theta power 4 equal to 0. But this is the value of uh, mod WA. Mod WA. That's what we have calculated. So if you WA transpose is 0. That's what we have calculated in the beginning. But then you take modulus square root, it will be remains 0 only. Okay, therefore the answer to this problem is 0. Okay guys, so if you like this video, please like the video. If you haven't subscribed it, please subscribe immediately and share with your friends. Okay, thank you guys.